Alright, I didn't do much. I only made the wiring to know exactly where to solder and what to solder. And there are three types of wiring here: data wiring, which is black; ground wiring, or negative wiring, which is blue. You see the sign here; and positive wiring, which is red. If you wonder how I made it, I'm using this Rotring pen, a mechanical pen that is having 0.5. It says there 0.5 diameter of the tip. You see, very thin. I'm using them from my artist years. Actually, this one I have it, as you can see, the rubber is no more here, as this one had. This I have it from 1900 and something, 997, 995. I was in high school when I bought it, and I'm using it from back then, and I was extremely surprised. This is not yellow, this is black, the black color, and this is blue color, and this is red color. And I bought these two guys recently by color, to be blue and specifically to be one blue and one red, to identify them very quickly and actually use. And I found them here in Romania, but with black tip there. But the colored tip crayon graphite, I purchased it from China, and it was quite expensive compared with the black ones, a little bit more expensive. It is extremely helpful to have these colors at this constant diameter all the time, not having to make a point, scratching. So I didn't do anything here on this board yet. I'm only preparing. I'm drawing it. I just finished drawing the wiring, and I just rechecked 2 times the entire wiring, looking on the circuit diagram and checking it here if everything is fitting and is going where it should be. And I made some mistakes. I had to erase, to replace. Also, I have all this. I made a pointer, a little arrow that is pointing that way. I'm not sure how good you can see it, but yeah, it's like a little triangle that is pointing that way. And that means this is the negative of the LED. These 3 are the LEDs. This is for floating, which will be red. 0 and 1, which both of them will be white, but a little bit slight color. You see, they are both white LEDs, but one will be cold white and one will be warm white. The top one is warm white, and the middle one is cold white, and this last one is red for floating. And they all 3 right now are pointing in that way, and I will have to unglue them, all of them, and reglue them in this position. Motherfucker. Motherfucker. But yes, right now I'm preparing, and I rechecked everything to be correct here, and I'm also preparing my machine, my homemade machine that I made for desisolator, for desisolating the wiring, the enamel on the wiring. Also here I prepared some copper wire. These are pieces of wire, scrapped wire pretty much, that I can reuse. And all this that you see here are from this little box here, from the scrap wires, and I will cut from them and link wherever I need. Yeah, it's a mess of wiring. It's a mess of wiring. I should actually think now, before I'm wiring everything, to actually add this pointer as well. I'm not sure how I will proceed, but yeah, I will see. All right, that's it. I wanted to show you the preparation for now. It is turning out quite a complex little circuit. It is deceivingly simple when you sit on the circuit here, when you actually have to make it. All right. I made all the connections, all the wiring is even under this paper. I have a couple of wires. Actually, those wires are uninsulated wires, and I put this paper on top of them for multiple reasons. And these are another layer of wires that are on top of those wires that are under this white paper that is stick there. And all the wiring is as in this diagram here. Everything is correct. For the probe, I didn't practically, I have to connect these 2 resistors together and link it with 1 wire to the probe. But what I did here, I did quick and dirty. I didn't connect them. I didn't have to, but I tested it already and it's working fine. I even switched the polarity. I put plus here and minus here, and everything got hot a little bit. But either way is working. Yeah, I'm quite pleased with the experiment I did already. So this is red. Let me actually close everything here. This is red for floating, and one of these wires is either plus, positive, or negative. If I'm touching it, nothing is flickering, which is extremely good, very good. I'm very pleased. And if I'm putting this to a certain rail, so this is for the negative. And as you can see, I hope you can see. Yeah, it's too much light from the window. If I'm putting it to positive, as you can see, it's a bit this red is ferocious, which is good. It's good. And this white and this white are not that ferocious. It's because of the resistance. I put 10 kilo, if I remember right. Pretty much, yeah. Excellent. So this is the test that I did. A quick and dirty test. Immediately after I wire everything, I even cut a little bit of the cardboard there. Next stage is to actually make the probe, the needle, and connect these 2 points to that needle, and practically I'm very close to the final device. And then to cut to shape, like that. And actually I will have to draw it and to double check it on the other side when I will get to the cutting, not to cut some wires there, because yeah, I have some wires very near to this here. I was imagining I will cut exactly in the line with this pad, but I will think probably I will leave a little bit of space there, and it'll be a bit wider. But it's okay. It's okay. I like it. I really like it because it's made by me, and I really like it. Yeah, it's a very fun project. I really like it. The problem, I'm thinking to use actually a nail, or a piece of copper wire like this. This is scrapped copper wire and probably bendable, you know, to bend it where I need it to be. It's an interesting idea, you know. But originally I was thinking to use a nail. Let me show you. Like this. You can because it's not a matter of resistance. That is iron or mild steel, the nail, and it's not really here. It's not a matter of resistance, and it is having a ton of resistance on these two resistors here. I'm not sure how to show you. Probably it's better from here. So it's already having 10 kilo and 10 kilo. And if you will add, let's say, 1 kilo more from the resistance of the material itself, the nail itself, it doesn't really matter. So you can actually put a nail, or even something that is not that conductive. Not very well conductive enough, but not like a shit conductor. And yeah, you can do that. But I will not do that. I will use a very good conductor, copper, very good conductor, because it's bendable and I can bend it. So it doesn't matter what material you are putting there, as long as it is a little bit conductive and not having too much resistance as the material itself is resistive. So that's it. All right, I think I made it, and let me plug it in. It's negative here, positive there. And voila, let me close all this light because, and if I'm probing positive there, negative here. These LEDs for 0 and 1 are both white LEDs, but one is cold white and this is warm white, but they are both white. But this warm white is way too yellow. It's because is this yellow because I run it at very low current, and if it's low current is and this is the red one. As you see, it's very bright. I actually made a mistake. Let me put this away here and show you a little bit how the construction, how it's made. And I made it very elegantly like that and like this, and I didn't glue anything. It's 2 cardboard pieces. This is for protection, and I can get back to the wires if something goes wrong. Actually, I did have a very bad problem. First of all, I on the circuit diagram here it says for the red LED, the floating LED, I had to put a 1 kilo, but here on this diagram I didn't insert. I put only the wire, the LED, the floating LED, the red LED there. I put the wire, and I didn't, because I put these resistors on these boards for these 2 LEDs for 0 and 1 for the floating LED. I drag only the wire directly originally from the pin, and then I realized, I have to put 1 kilo here, 1 kilo resistor, and I also draw it here. But in the moment I assemble it, I overlooked absolutely totally that is a resistor there, and I linked the wire directly to the pin. And thanks God I didn't burn it, but it was extremely vivid. The previous test that I did, actually, it was like that. And then I had to, I hope I can, let's see, enhance. I have to get in, yes, like that. So I have, you see, it's a resistor there. I put a cardboard, I glue it on the cardboard, and then the wire, I drag it a little bit longer. It was a little bit longer. So I had a lot of luck with this wire, that it was left a little bit longer, and I could stretch it until I reached that side. And then I bridge the other side of the resistor to the actual pin. And this was one problem. And another problem to solve. And another problem, immediately after I soldered that, I stressed this pin. And I didn't realize stressing it by bending this cardboard, which is extremely flexible. Also, this guy's here. And I was getting errors when it was interrupting on and off while I was moving and I checked every single wire to see if its connections were, unsoldered somewhere. And I couldn't find anything until little by little I spent probably 1 hour to find the problem. And it was this negative pin here. I probably put it back, but I had, right now it's having, so I repaired it actually a couple of times. Let me actually zoom in very close to it. You see right now it's having this wire that is bent. You see, it's a little bit bent, and it's very flexible wire. That's why I bend it to offer some flexibility, some springiness. If it's not bent like that, so the wire is like this, and if something is moving, the wire will move with the cardboard or something. Before I had very stiff, extremely stiff, very strong and very thick piece of wire there to this pad linked, and it literally unsoldered from that pin. But the way it did it, it was very strange because I couldn't see shit. So this was the idea. So this is the pin of the leg of the chip, like that. And if I'm soldering something here, it was like a little bit of crack between the solder, and it looked like it is already soldered and no problem there. But for some reason, behind it was springed. It springed out, and I couldn't, even if I push it like that. Sometimes was making contact, sometimes was not making contact. Intentionally, I was poking that solder point, and sometimes was working, sometimes was not working. So I, in an hour or 2 hours of checking every wires here, I even bent this wire, push it because it was very close to this one, and I was thinking for certain it is making contact there, but it wasn't. So yeah, you get shit, you get some shit, but you have to deal with it. You have to be able to repair it and stick with it. And that's it, pretty much the problems that I got. And another problem, after realizing that missing resistor, I put 1 kilo, and when I tested it, it was very, very dim. So I changed it with 300 ohms instead of 1 kilo. Now it's also very bright, but it's having a minimum of protection, of current protection. It's a minimum, and it's good enough. And this is the probe that this is the probe pad. I put a wire, as you can see, yellow wire here from this resistor there, and here a stiff link, a stiff wire like that, and they are both connected in the same point. This is a very good idea that I came with because it doesn't have to be in the middle. Nowhere. It is not a written law to be in the middle. So it can be on a side like this. And also, it was already disproportional. This side was bigger than this side. So I said in my mind, well, I can use it. And originally, I was thinking to use a wire like this. And that's why I made it so long, to actually solder this wire here. And then to bend it wherever I want. But then I thought, if I want to be smaller here, to actually insert it here in the hole, because the thickness of this wire is not good enough for this hole. It doesn't enter there. So I said, well, I should probably use these pin probes that I'm always using for testing. These are not great. They are very thin, and they are playing a little bit inside the hole there. But they are good enough, you know. And then I put longer wires like this, but they are too stiff. They are too stiff. You see, and they are too like two springs, and I have to bend it quite hard to put it in position, and also too short probably. Either I will have to add new wires and longer wires. And I like this design that I made it like this with this cardboard blocks, if you want, because I can assemble it and disassemble it very quickly and check for potential errors, potential problems. And of course, I don't want them, but yeah, I'm quite proud of this design. Oh, I have to put this guy here, the protection. I even have some marks here and here, just like that. And this is entering by force, very forcefully, especially here, like that. And it's not playing, it's not moving anymore from these two different parts. And then this guy here. If you wonder how I made it exactly as you see it here. I bend it like this, piece of cardboard directly on this on my tool that I'm having here, and then I press it and I keep it pressed to fit press. When I'm taking it out and when I'm pushing it in, it is a little bit fit pressed. And these two ears that I made, and also on the other side here, if I can take it up, and this they offer some springiness. You know, they are pushing aside, and is like a little bit of spring, and it's helping a little bit of. You see how a little bit hard in the end, and it's. Yeah, it's very detachable. I can disassemble very quickly and put it back very quickly, and that's what I like it. I like it very much. The prototype. This is a basic probe, and now let's test it again. Let me actually add my clocky, Mr. Clocky. This is a 555 clock, and I'm using it right now as a test only. Positive, yeah, negative somewhere there. It's starting to clock, and this is the signal wire. Let's see my probe. How it will work, my probe. Oh, I also put some plastic, so I soldered it to a pin, the wire to a pin, and then I 3D printed with plastic, with molten plastic. I have it here. It's a PA, polyethylene. And how do I know it is polyethylene and not something else? Because the bottles and the lids of the bottles are having this marking 02 or number 2 on this sign inside them. I'm looking on them, and sometimes they are actually telling either PA, HDPA or PA-HD. So these are possible markings. Usually it's like this without any writing. It's only 2 and that's it. And but I have all the possible variations, and that's the plastic that I reused here. I melted it and reused. So yeah, it's pretty. You know, it's good for from bending, not to get not to get damaged. You know that I have to resolder it again. You know. And now let me put it back, and voila. And when it's positive, when this LED is lighting up, the blue LED is lighting up, the yellow one represents 1. And when it's off, let me actually put it the slowest. This is 1 second, 1 hertz, 1 bit per second. And yeah, it's probably not making contact, and it's lighting up a little bit, that red LED. Yeah, I love it. It's good. It is good. Like I said, the wiring here are not that good. I don't like them. For the moment, I don't like them. I will have to rethink a bit more. When I was bending all this, you see how everything is bent like this. That stiff, very stiff pin that I put it to the leg of the chip here was getting off when I was forcing, especially the black wire. And and it was starting to work and not work, and holy shit, it gave me a ton of problems, and then I realized what is going on, and yeah, whew. Let's see if I'm taking the power off, it remains as a 0, really? Oh, because that is a 0, okay, and if I'm putting on positive, it remains as a positive, very interesting. So something positive on the probe if I'm taking out the negative lead from my clocky, very interesting, cool, eh? Yeah, and now if I'm moving it very fast, yeah, you see, so this is about 1 kilohertz, up to 1 kilo, 70, no, 50 hertz, 50, 70 is not really linear, it's very non-linear how it's running here. So this, when it's trembling a little bit, I can see it trembling, 40 hertz. So this is 40 hertz when it's visible. Yeah, 30 or 40 hertz when it's visible flickering like that. But after, if I'm going into 50 hertz, it's not visible. It's kind of visible, but not really. And if I'm going to high, is now this flickering that you are seeing right now. This is what I call it. I call it a relative reading. So this probe is relative to the flickering that is getting here. My next upgrade to this probe is to add a constant, not a relative reading. So after 20 hertz, ow, that's why I don't like it. I don't like this stiffness, this springness of the wires that I'm having here. Let me put them a little bit here on the other side, there, like that, to not hold it in my hand. Actually, I love it. It's very cool. So let me actually film it like this, because it is cool. It's too fast probably. Now you see, yeah, it's cool. I love it. And when it's let's see, and when it's not like that, back. Yeah, I have a little bit of problem when I'm touching the probe. You see, is getting this LEDs very faint, but here in the camera is looking like they are fully bright, but it's quite faint, and it shouldn't have been this sensitive. I was thinking 20 hertz as a base of working. So less than 20 hertz to be relative reading. So right now is relative. The oscillation that my tool is doing right now is relative to the clock speed. Right now if the clock speed is 5 hertz, the relative speed of my instrument is also 5 hertz. So it's listening exactly what kind of frequency the device is putting. And if it's only one, if it's 0 hertz or constant, or only one single level, like right now I'm probing only one rail or the other rail. This is also relative. It's not moving at all. So it's less than 20 hertz. But if it's more than 20 hertz, as you can see right now, it is relative to the frequency that is reading, and it's not nice because sometimes if I want in the future to read I don't know, some processor, some RAM, some computer internals or something logic, that is at a very high frequency, and if this is relative to the frequency that is reading, that is actual, it will show only this kind of reading, and I will not really understand what is going on. I will probably think it is a bug or an error, and I will not know if it will actually be something 0 and 1, or I don't know. But my idea was, and I've seen this probe on someone else on YouTube. He was showing some probes, not some probes. He was using his probe, and his probe was not relative to the frequency. It was constant oscillation, indifferent of the frequency. So if I'm right now, if I'm 20 hertz, if I'm 30 or 1 kilohertz, this blipping was constant all the time, indifferent of the frequency I was putting it to the reading. He was indifferent of the reading, and yeah, that's the next upgrade that me and my friend, my English friend from England, and we are trying to make it work. I believe he actually find a solution. This is his circuit, this constant frequency. I only bring in the problem that I want to solve, and he solved it for me. And all the praising to him here at this point. And so that's the next upgrade. And he actually find a chip, an integrated circuit that is monostable and dual monostable elements inside the chip, and they are both reading something. And yeah, it's a very new chip for me, and it's very interesting, and I will have to wait until it will arrive. Another upgrade that I want to add to this logic probe that I made here is a buzzer to actually beep when it's changing from 1 or 0, and yeah, it will be cool. By the way, what I'm having here is consuming 4. It just changed motherfucker into 5. Now it's usually 3 or 4 30 or 40 milliamps. It's a bit high, 40 milliamps. Probably this stuff is using a lot of some current as well, probably, but we will see. The idea, what I'm showing you here, I'm showing you all the problems I had along the way and how to solve them, and I'm showing you that if you want to build something like this, you will get into problems like I had, and don't be discouraged. And even if it will take you a couple of hours to debug the problem and to find the motherfucker that broke, like I had there, that problem, and the problem with the resistor as well, just take the time and resolve the problem until actually you see, you find the motherfucker and repair it, and after you repair it, you have absolutely no problem, and you will be absolutely, it will be an awesome feeling. Trust me on that, because this is good. This is nice to have something that you build it yourself and it's working exactly as you imagine it in the beginning before starting making it. One little bit detail. When I was having that problem on the leg, I was suspecting a lot of problems along the circuit, and I couldn't find anything. But along the problems was the wires. I was bending the wires, and sometimes was working, sometimes it was not working. Let me do it, keep it like this. So if I'm bending the wires here, it was giving me a lot of interruptions, and it was on and off all the time. And if I was doing like this, if I took out this case that I have, it was not giving me too much problems, but it was giving me a lot of problems when the case was inserted, way more faster and more frequent, the errors I was getting. And I started to put head-to-head a lot of errors, and I didn't see it. I didn't see the rupture, the gap between the pin and the solder. I didn't see it, and I couldn't see it when I was pushing it. But I deduced from all the errors that I got when I was bending everything and I was checking, and it started to hint me towards the real problem, and very, very subtle hints, extremely subtle. I almost got lucky to find it. That is the motherfucker that I was kind of partial luck, but I was bending everything pretty much, and I was checking with my tweezer, and with my needle. I was checking every contact, everything. So yes, I hope you like it. Thank you very much. This is it. Learn from my experience, and when you have to do your stuff, don't get discouraged. Try again until you manage to make it work, and even if you get errors, doesn't matter. Nothing matters on this world if you get stuck on errors and you don't push forward. This is a Romanian mentality. This is not an American mentality. This is a Romanian mentality, and I'm telling you just to be insistent and progressive and push forward because it will be good in the end. Not in life, but with stuff, because in life, as I am an artist, I'm never getting money on what I'm building. I'm experimenting on my money and on my time, and I don't have a job. I cannot have a job with what I know, with my art, with my electronics, with my mechanics, and I know a lot of stuff. Quite professional. I can say I am quite professional at some levels in some domains, especially in my art. I'm not quite. I am actually a professional in my art department, but in other areas, parallel to my field, like electronics, like a lot of stuff, and it's impossible in capitalism to make money. Maybe it's possible in America, but and in Russia or in Germany, but or the rest of the Europe. But the east of the Europe, but the west of the Europe is nah. We are in the Middle Ages, in the Black Ages here, and in the Dark Ages, and yeah, with new technology, playing with new technology. But it's impossible. It's not really. If you know a lot of stuff in capitalism, you will not succeed. It's better to be an idiot in capitalism than to be a smart guy, and you will have a lot more success being an idiot than being rational and knowing stuff like I do, and many others like me. I bet it is the same. So the capitalism failed me big time, and I'm very, very upset on it. And the people that are sustaining it is lying that it is a good thing. It is not a good thing at all. So I will leave you with this, and see you later, alligator. And bye bye from your favorite artist electronist. Bye bye. All right. Well, here on the camera probably it will look quite strong, but in reality it's not that hard light that I see on this and this one when I'm touching the probe with my hand. And it's not my 50 hertz that my body is catching, because if I'm grounding myself, if I'm touching the earth, and my earth, I just check it now, it is connected. And if I'm touching the earth, you see the light is changing a little bit. You see it becomes a little bit more a tiny bit more intense. So now it's intense, now it's not intense, now it's a bit more intense, now it's less intense. So this is normal without me touching the earth, and this one is a little bit intense, is me touching the earth. So it's not the 50 hertz that is catching on my hand, it's something else. I'm not sure exactly what. It's very, very interesting. And you see, this is almost visible, So I'm touching it like this. You see, it's almost visible. And if I'm squeezing, you see, it's pressure sensitive kind of. You see, when I'm squeezing it, it's getting more intense. So this is a phenomenon that I don't want to have it, and I didn't have it when I had it here on the board with the chip and with those two transistors. And what I suspect is this 3 kilo from the base to emitter, and here as well from the base to emitter, this other 3 kilo. I used the value that I used here, and it worked fine, and it is working okay here as well, exception with this exception with this, when I'm touching it is lighting up, and it shouldn't. If I'm changing that value, I'm not sure if lower or higher, because it's kind of a middle, if you go to high or go to low in the resistor value, it will give you erroneous output, and it's quite on the edge of the knife. It's you have to balance it, but you have quite some room to balance it. I guess up to 10 kilo probably, or less. I don't know the maximum and minimum when it's giving the error, but this is part of the error, and probably it's too low or too high. I'm not sure this value, so I will have to change it, and I will come back to you with a new video after I will change it, because this was the last thing I left it to resolve. After I will build this entire circuit with the new transistors that I use there, the SMD transistors. And they are different transistors than those. One is brand new, but is kind of used in my experimenting. But it is from a bag full of brand new transistors, the NPN. And the PNP is practically saved from some boards. It's scrapped. It's totally scrapped. And that's probably the only reason I was getting some errors in the beginning. But with this guys, the brand new guys, I have to tweak a little bit more this 3 kilo that I'm having there. Yeah, I'll see you hopefully when I will resolve it and not screw it up. Hopefully, we'll see. I'm very curious if it will be resolvable. Just as a curiosity, is this between these two pads and this other one that is also between these two pads. So that's 302. I believe you can see it even. No? Yeah, it's exactly 3 kilo. 3, 0, and 2, 0. So that is the 302, the 3 kilo that I took out from there. Only one place for now, but I want to show you how to test. I want to show you how I am testing the pin. So I will plug it in though. So negative, this is positive, and what it was problematic. Let me close. It was when I was touching the probe, right? Now it's not working correctly because I took out that resistor. That is an essential resistor there. So here I have 1 kilo, and I'm testing it like this, pretty much. Yeah. So if I'm touching. No, it's too low. Like I said, if it's too much, if it's too high or too little, yeah, you see nothing lights up. When I'm touching it is lit up. The floating LED should lit up. So 1 kilo is too low at this point. Let's see, 10 kilo. I should put 2 wires and drag them there and test there, actually. That will be a bit more elegant, but for now I will test it directly on it. So let's see with 10 kilo what it's doing. Now it's with 10 kilo. It's doing the same thing. Motherfucker. Well, but that LED, the one is staying on. Okay, so doesn't like it. Okay, I will put 2 wires and probe it here and test it here until it should work in the end. Now it's more like it. So it's like not having nothing. It's like having nothing. Right now it's not having anything there. So it really needs leakage. So when I'm putting 10 kilo, so this was the test I made originally with those transistors, but not with this SMD transistors that I'm having right now. I put in parallel a couple of resistors, and now I should get the red. Yeah, I get it, but I still have that leakage on those LEDs. So this is 3.3 because it's 10 kilo on parallel, and let's tweak from here. So I will put all these 3. Actually no, I will get my big board, and this is my big board of resistors, and I have 3 kilo already here, and I will put gradually down and see what is happening. As you can see, I have a hole there. So I will put now almost 3 kilo. It's 2.7. Let's see what is happening right now. 2.7. Okay. Yeah, I think it's better. And yeah, I think that is the one. 2.7. All right. Okay. And now let's see. 2.4. The next value. Like this. Right. Oh yeah, you see that one here is not lighting at all. Or if it is, yeah, come on, what's going on? Come on. Probably, what the fuck is going on here? Yeah, no, I think this is it. This is the, it probably didn't make a contact because this pins that I'm having here, yeah, 2.4. Well, it's in the border, in the very margin of the, who knows, 2.4. Let's see, 2.2. Maybe this is a winner. It is lighting a tiny little bit. Let's see the 2.2. Yeah, absolutely nothing. Huh? No, I don't see it. Probably I see the light from this other one, on that one. This is 0 that is lighting, and this is 1 that I'm testing. So absolutely nothing. I'm not sure how well you can see. I think you can see. So this is how. So 2.2 in this case, it is better. It is better with 2.2 instead of 3. It is a very fine tweaking. And now I will have to search a 2.2 resistor and change it, put it there and also there, because this I consider them the same, although they are not the same. But I consider them brand new, and they, even if they are not the same, they are brand new comparative with these guys that I had before, and it worked okay with 3 kilo. So it seems with 2.2 kilo is the optimum for this to have a good feedback, a good result from it. All right, see you later when I will change it. I hope you liked my experiment here to show you how I'm doing stuff. All right, said and done. Never doubt yourself, at least me. So now when I'm touching the probe, nothing leads. Actually, I have this guy. I'm not sure how. Yeah, it is. It is showing on the camera. Huh? It is showing. Are you showing on the camera? No, it's not. Huh, weird. And when I'm standing here, it is. If I'm touching the ground, if I'm touching the ground, I don't wear a vest on me. I touch with my skin the iron of my table, and my table is made from iron and it's grounded. And when I'm touching with my elbow the ground, and if I'm touching here, you see those two guys are lighting up. But if I'm not touching the ground, if I'm touching it with the hand in air, it is absolutely awesomeness. Nothing less. I believe a little tiny infinitesimal is lighting up the zero, but infinitesimal, almost imperceptible. So I love it. I love it. It's exactly what I wanted. It is exactly what I wanted. So yeah, problem solved. Problem solved. This is it. This is me putting the lid on like that. Do you like my design? Pretty cool. Pretty cool. Love it. I love it. This was the solution that my friend from England find it. Actually, this was his solution, and all the praising to him. But I did work myself to death, trying everything here on the actual circuit, and yeah, it's working absolutely cool. So this is a basic logic probe. What I did here, checking the floating right now, and let me put my oscillator here that I'm having. Let's see if it's reading correctly. It is reading correctly, and here as well. Good. And let's see it actually. I'm having some what? Yeah, whatever. So let's see how it's working with an actual oscillation. Like I'm putting it to some sort of to actually test the thing, and it's working absolutely fine. If I'm touching the probe, yeah, if it's moving a little bit because these probes that I'm having are very thin here, are moving inside there, and you can see a disconnection. So if I'm touching them, but this is catching it, which is pretty interesting. Yeah, and also when I'm changing from here, why something is still moving? Probably this wire here is moving because I'm using the same probe. Let's put it like that. So I was getting some errors when I was moving this circuit in this box. But if I'm taking it out from the box and moving it around, I'm not getting that error, that floating error. I was starting to think that 2.2 kilo is too sensitive, too low, and it's increasing the sensitivity. But when I'm rotating now, I'm not getting any red LED here on the probe, and it's probably touching or squeezing something inside this circuit. Yeah, it's already detecting some weird behavior from my other circuit that I'm having, and I will have to make it another box most probably, because this box I don't like it anyway. So yeah, cool. All right, it's working. It's okay. It is okay. It is okay. So my logic probe. All right, and my funky oscillator here that I had to. So now if I'm putting it in the box here, it's having a special position actually. When I'm moving it, I will get that floating. Now it's not doing funny business, but it does. Motherfucker. It does, yeah, you see, now it's doing funny business. So yeah, sometimes when it's pressing, I'm not sure, when I'm pressing here, you see, there. If I'm keeping it in a special position, I believe, yeah. If it's moving, it's squeezing the circuit inside, and it is moving like that inside this box, and it's probably making some weird contacts sometimes, and this guy is already detecting it, which is cool, which is very cool. Yeah. Okay, so this is it, problem solved. So now if I'm taking the probe out and I'm putting my fingers on its probe, it's not lighting up those two other LEDs. I'm not sure what the camera is seeing. Yeah, it is. Huh? Oh no, I was touching again the ground. I was touching the ground with my skin. Now I'm touching the ground. Now I'm not touching the ground. My table actually. My table, which is grounded, and that's why. But if I'm not touching the ground, if I'm careful and not touching the ground, let me take out this guy that is bleeping like crazy. So now if I'm not touching the ground and touching the probe only, without me touching the ground, excellent. Is exactly what I wanted. So, yeah, problem solved and mission completed. All right, I'm very happy about it. I'm very happy about its progress and the design, how it's looking as a probe. Very cool, very cool. I should write on it, to actually know in the future what this thing is doing.